In this lecture here, we want to move into section 1.4 and talk about what in mathematics what's referred to as a complex number. So the objectives that we're going to talk about in this lecture are how to add and subtract complex numbers, how to multiply complex numbers, how to divide complex numbers. So really what you can see here in this first part here, what we're looking at is operations on complex numbers. Okay, and then what we'll do is we'll perform operations with the square root of negative numbers. Okay, so you might be like, well, you can't take a square root of a negative number, and that's where we're going to introduce complex numbers and what's called the imaginary unit. Okay, so let's begin. So what exactly is a complex number and imaginary numbers? So in mathematics, we define what's called the imaginary unit, and it's referred to as I. Okay, so I'm going to write it like this, is equal to the imaginary unit. Okay, this is my I. So whenever you see this little tail on it, this is how I write the I. So I is equal to the square root of negative 1. So right, you can't take the square root of a negative number. So we say that the square root of negative 1 is an imaginary unit. Okay. It turns out then that I squared, so look, if you think of I is equal to the square root of negative 1. If you square it, well, when you square a square root, the square root goes away. So I squared has to be equal to negative 1 then. Okay, so this is the imaginary unit. So then the set of all real numbers of this form, a plus bi, okay, where a and b are real numbers and I is the imaginary unit, is called the set of complex numbers. And this is the standard form for a complex number. Okay, this a is called the real part, and this b times I is called the imaginary part. All right, so for example, let me give an example of a complex number. Something like 5 plus 7i. That's a complex number. All right, or negative 3 minus 4/5 I. That's also a complex number. Anything of this form where it has this real part and then this imaginary part to it, that's a complex number. So now what we want to do is we want to perform all these operations, okay, on complex numbers. Okay, so the form of a complex number a plus bi is like a binomial. Okay, so we know the binomial. We've talked about that before. So a plus bx is just like that. Okay, so to add, subtract, and multiply complex numbers, we use the same methods we would use for binomials. Okay, including even the FOIL method. Okay, so anything that you would have done for binomials, you can do for these complex numbers. We're going to use the same methods. Okay, so let's start by doing some adding and subtracting of complex numbers. So let's perform the indicated operations, writing in standard form. And so remember, standard form is this form right here, this a plus bi. All right, so let's look at the imaginary number 5 plus 2i, and I'm going to add to it 15 minus 8i. Well, what you would do is you would take the real parts, the 5 plus 15, and then you put next to it the imaginary part. So plus 2i minus 8i. And then you treat the 2i and 8i like terms. So you can just, in this case, subtract the coefficients. So 5 plus 15 gets me 20, and 2i minus 8i gets me minus 6i. And that's it. That's all you do. So treat this, as as you would if it was an x for performing this simple stuff here. Now let's look at minus 12 minus 5i minus 8 plus 7i. All right, so we have this subtraction here. All right, we'll just do the extra step and distribute the subtraction part here. So minus 12 minus 5i. Minus becomes plus, so plus 8. And then minus plus becomes minus 7i. So now I'm just going to rearrange. So this is minus 12 plus 8. Minus 5i minus 7i. Minus 12 plus 8 gets me minus 4, right? And then minus 5i minus 7i gets me minus 12i. And that's it. And that's very, very simply how you do addition subtraction, okay? Very, very, very straightforward process. Okay, now let's talk about multiplying, okay? So let's find the product here, okay? And then again, what we're going to do is we're going to write in standard form. Let's just even start with something simple like this. Let's look at minus 5 times 10 minus 6i. So here you're literally just going to distribute. You're going to go minus 5 times 10 gets me minus 50. Minus 5 times minus 6i here, so negative negative becomes plus 30i. Let's try this one. 3i, ooh, so I got an I outside, times 5 plus 2i. Well, 3i times 5 gets me 15i. Now watch this. 3 times 2 gets me 6, and then what's I times I? Well, I times I gets me I squared. Well, recall, okay, whenever you see I squared, that's equal to negative 1. So I'm going to replace that with negative 1. So that's going to become 15i minus 6, and then writing in standard form, I'm going to put the real part first, minus 6 plus 15i. All right, let's just try this last one. Let's look at 2 plus 3i times 4 minus 5i. All right, so literally what's going to happen here is I'm going to FOIL. 2 times 4 gets me 8. 2 times minus 5i gets me minus 10i. 3i times 4 gets me plus 12i. Now watch this. 3i times 5 minus 5i. So 3 times minus 5 gets me minus 15. And then what's I times I? That gets me I squared. So now I'm going to replace the I squared with minus 1. And now look, negative negative becomes a positive. So this is 8 plus 15 minus 10i plus 12i. Well, 8, remember the reason it's plus here is because minus minus. So 8 plus 15 gets me 23. Minus 10i plus 12i gets me plus 2i. So basically, what I treated this with was, just like if it was a binomial, but here, just remember, whenever you see this I squared, okay, you can replace that with negative 1. All right, so now before we talk about division, we got to talk about what exactly is a conjugate of a complex number. Okay, so for a complex number, a plus bi, we define its complex conjugate as a minus bi. So whenever you see something of this form, a plus bi, all right, its conjugate is a minus bi. Or if you have a minus bi, its conjugate is a plus bi. So it works both ways like this, okay? You're just going to flip the middle term. So it turns out when you take the product of a conjugate, it ends up just being a real number, okay? So if you take, and here I'll even, this is written out here, but if you take 2 plus 3i and multiply it by 2 minus 3i. 2 times 2 gets me 4. 2 times minus 3 gets me minus 6i. 3i times 2 gives me plus 6i. And 3i times minus 3i gets me minus 9i squared. And look what happens. The middle terms cancel out, like you see here when I leave the letters in. And the I becomes negative 1, so this ends up being 4 plus 9, or 13. Which is the same thing as a squared plus b squared. So if you multiply the conjugates, you can just realize that this is just 2 squared plus 3 squared, which gets me 4 plus 9, which gets me 13. So you can just very, very easily skip the FOIL step, all right, when using this formula. Okay, so whenever you have conjugates, a plus bi times a minus bi. It's just a squared plus b squared. So for example, if I have 4 plus 2i times 4 minus 2i. Okay, that's just going to be 4 squared plus 2 squared, which would be 16 plus 4, which would be 20. So it's a real nice trick. So going forward, whenever we see conjugates like this, complex conjugates, we're just going to be, oh, we could just use this formula. It's a squared plus b squared. All right, the reason we do this is we use it for division. So the goal of complex number division is to obtain a real number in the denominator. Okay, so whenever you have a complex number in the denominator, you're going to have to somehow transform it to a real number. So to do this, we multiply the numerator and denominator of a complex number quotient by the conjugate of the denominator to obtain its real number. All right, this seems a little bit harder than it is, but it's actually not too bad at all. Okay, so let's do this problem. Let's take, I'll do a couple examples. Let's take, we'll start with this actually. 5 divided by 3i. Whenever, this one is not going to involve the conjugate. Just notice whenever you have an I in the denominator, okay, what you're going to do is you're just going to multiply by I over I. Now watch what happens. This becomes 5i over 3 times I squared, because I times I becomes I squared. So that's -1. Or just, you can move the negative in front, 5i over 3. So that's simple. Whenever you have just an I by itself in the denominator, just multiply by I over I. But now this is a little bit harder. When you have something like this, 3 over 2 plus 5i, okay? And you're going to want to write this in standard form. So what you're going to do is you're going to look at the denominator and be like, oh, the denominator is a complex number. So I'm going to multiply everything by its conjugate. So I'm going to go, the conjugate is 2 minus 5i, and I'm going to multiply also the numerator by 2 minus 5i. So multiply across. This becomes 3 times 2 minus 5i all over 2 plus 5i times 2 minus 5i. So I don't distribute this until the end, just in case you can simplify the denominator, but let's simplify with the denominator. That's not always the case, though. So here, conjugates, boom, complex conjugates. So this is going to become 2 squared plus 5 squared. So this is 4 plus 25. So that's 29. So what happens here is the 3 can't cancel here. So I'm going to distribute the 3. So this becomes 6 minus 15i over 29. And then your final step is you have to write it in standard form. So you have to split it up. So this is 6 over 29 minus 15 over 29i. I just split the fraction up, okay, just so I could write it in the standard form. So I got the real part and then the imaginary part. So this is the real part and then the imaginary part. All right, let's try another one. Let's look at 3 all divided by, so let me do 2 minus 3i. We'll just do a simple one like this. All right, so I got a complex number in the denominator here. So I'm going to multiply the numerator and denominator by the complex conjugate. Multiply across. So this is 3 times 2 plus 3i all over 2 minus 3i, 2 plus 3i. Okay. Complex conjugates. So this is 3 times 2 plus 3i all over 2 squared plus 3 squared. Well, that's 4 and 9. Well, that gets me 13. So now realize that the 3 and 13 won't simplify, so distribute. So 3 times 2 gets me 6, plus 9i all over 13. And then in the last step, just break it up, because you've got to write it in standard form. So it's 6 over 13 plus 9 over 13i. And we got it. All right, the last thing I want to talk about is how you simplify with a square root. So for any positive real number b, the principal square root of a negative number is defined as, okay, so whenever you have negative b. What's really going on here, this is supposed to be b, is this is the square root of negative 1 times b, which you can break up as square root of negative 1 times square root of b. But then what's the square root of negative 1? That's just I. So you'll see me a lot of times, I'll write this as the square root of b, and then outside of it, I'll write the I. All right, so really what's going on here is, look, you can think about it this way, okay? You can factor out a negative under a square root. As the imaginary unit I, okay? So let's do a couple examples here, all right, just so you can see. All right, so let's perform the indicated operations and write the result in standard form. So let's actually just do one that's going to be really cool. So this is square root of minus 25 plus the square root of minus 36. All right, well, do you notice each of these have a negative? So let's factor it out. So this is the square root of 25 times I plus the square root of 36 times I. All right, so whenever there's a negative under the radical, it comes out as an I. Well, the square root of 25 is 5, so this is 5i. Square root of 36 is 6, so this is 6i. So 5i plus 6i gets me 11i. All right, let's try this one. The square root of minus 27 plus the square root of minus 48. Okay, negatives. All right, so the negatives comes out. So this is the square root of 27i plus the square root of 48i. So now we're going to simplify these radicals, right? So 27 is 9 times 3. 48, I think, I think this is 16 times 3. And the reason I did that, right? What's the square root of 9? The square root of 9 is 3. So this is 3 times the square root of 3i plus 16. Well, the square root of 16 is 4, so this is 4 square roots of 3 times I. Well, look, square root of 3i, square root of 3i. So 3 plus 4 gets me 7 square roots of 3i. All right, and let's just end on this last one here. Let's look at 2 minus the square root of minus 3 squared. All right, well, okay. First off, under the radical, that comes out as an I. All right, so what is this squared? Well, this is times itself. So you're going to have to FOIL, okay? So be very, very careful as we do this. 2 times 2 gets me 4. 2 times minus 3, the minus the square root of 3i becomes 2 square root of 3i. Now look here. So this also becomes minus 2 square root of 3i. Now this is interesting. Okay, minus becomes a positive. Square root of 3 times square root of 3, well, that becomes the square root of 9, which is just 3. And then I times I becomes I squared. Well, what's I squared? So this becomes 4 minus 3, because this is now minus 3. Minus 2 square roots of 3i, minus 2 square root of 3i. Well, 4 minus 3 just gets me 1. And this now becomes minus 2 minus 4 square roots of 3i. So just follow your operations, okay? And remember, whenever you get an I squared, it's just equal to -1.